Imagine, you're standing on the surface of another planet. The Martian sky stretches above you, a dusty, rust-colored expanse of nothingness. The wind stirs gently, lifting small grains of sand. The air is thin, and the temperature is cold. But something more than just the Martian atmosphere hangs in the air. This is the beginning of something extraordinary. You look around, and suddenly something catches your eye. An odd shape, a pattern that doesn't seem quite natural. Could it be a fossil? An ancient sign of life frozen in time, waiting to be discovered after millions of years? This moment could be real, but it's not on Earth. It's happening on Mars, February 18th, 2021. NASA's Perseverance rover finally touched down on the Martian surface, and when it did, the world collectively held its breath. This wasn't just another rover mission. This was the culmination of years of work and anticipation, aimed at answering one of humanity's oldest questions: are we alone in the universe? Perseverance, or Percy as it's affectionately called, was designed to search for signs of ancient life, life that might have once thrived on Mars. It's equipped with a suite of high-tech instruments, cameras, and tools to explore the red planet in ways we've never done before. Its primary task? To search for microbial life. But to understand why this is so significant, we have to first understand Mars itself. Long ago, Mars wasn't the desolate, barren world we know today. Billions of years ago, the planet had a much thicker atmosphere, a warmer climate, and liquid water, oceans, rivers, and lakes that covered much of its surface. Scientists think that in its distant past, Mars may have supported life. But somewhere along the way, the planet lost its atmosphere, its water, and with it, any potential for life as we understand it. However, evidence of that ancient past remains, trapped in the rocks and soil of the Martian surface. When Perseverance landed, it began its journey by exploring Jezero Crater, a site chosen for its ancient lakebed and delta, where water once flowed. It's here, in this ancient Martian landscape, that something truly incredible happened. On its mission, Perseverance captured a series of high-definition images that sent shockwaves through the scientific community. The rover's cameras photographed strange formations on the Martian surface, ones that looked strikingly like fossils. These formations appear to be round, flat, and remarkably similar to the microbial life found in ancient rock formations on Earth. Could these shapes be remnants of Martian life, fossils of microorganisms that once lived in Mars' ancient oceans? Or are they simply the result of natural geological processes that mimic life forms? At first glance, the formations seem too organized, too symmetrical to be just random rock patterns. They appear to show an almost biological structure, suggesting that perhaps Mars once hosted life on a microbial scale. It's the kind of discovery scientists have dreamt of for decades. But as thrilling as it is, it's important to note that we can't jump to conclusions just yet. These shapes could still be the result of mineral deposits, weathering, or other natural processes. They might not be fossils at all. But they are, without a doubt, one of the most intriguing discoveries we've made on Mars in recent years. The question now becomes, how do we know for sure? How can scientists determine whether these formations are truly signs of ancient life, or just a coincidence of nature? The key lies in the next phase of the Perseverance mission, and it's something scientists are incredibly excited about. Perseverance is not just taking pictures, it's gathering samples. For the first time in history, a rover on Mars is collecting rock and soil samples, which will eventually be sent back to Earth for analysis. These samples are crucial because they will allow scientists to look at the chemical composition of the rock in great detail. Could the formations show the kind of chemical signatures we associate with life? Could they contain organic molecules, complex carbon-based compounds that are the building blocks of life? And if so, what does that tell us about the possibility of life on Mars? But there's another layer to this mystery that makes it even more thrilling. Perseverance isn't working alone. It's also part of a larger mission, known as the Mars Sample Return Mission, which will eventually bring Martian soil and rock samples back to Earth. This collaboration between NASA and the European Space Agency will allow scientists to study these samples in Earth's laboratories. With the full power of human ingenuity, behind the investigation. This could be the breakthrough we've been waiting for. Proof that life, in some form, once existed on Mars. But there's a catch. There's always a catch. Even if these formations are proven to be fossilized life, it raises a host of new questions. What kind of life was it? How long ago did it exist? And, perhaps most perplexing, why did Mars, once a potential cradle for life, lose its ability to support it? Was it a cataclysmic event that wiped out Martian life? Did the planet simply evolve into an inhospitable place over time? These questions will need to be answered, and that could take decades of research, collaboration, and exploration. Now you might be wondering, could life still exist on Mars today? Could there be tiny microbial organisms still hidden beneath the surface, shielded from the harsh Martian environment? Some scientists believe it's possible, and there are even theories that life on Earth may have originated from Mars, carried here by asteroids or comets. If we find life, whether ancient or present, it would completely transform our understanding of life in the universe. But for now, all we have are these images, shapes in the rocks, clues in the dust. And yet, even these small signs can offer hope, the kind of hope that pushes humanity to look beyond the stars and question everything we thought we knew about our place in the cosmos. So, what's next for Perseverance? Well, the rover will continue to explore Jezero Crater, looking for more signs of ancient life and studying the geology of Mars in unprecedented detail. And as it does, scientists will be eagerly awaiting the day those first Martian samples are returned to Earth. What they'll reveal could change everything. But as we wait, I want you to think about this. If life was once possible on Mars, what does that mean for the potential of life on other planets, moons, or even distant exoplanets? Could there be other places out there where life in some form is waiting to be discovered? The universe is vast, and the possibility of life may be more common than we ever imagined. Now that we've set the stage for this groundbreaking discovery, let's dig deeper into the science behind what Perseverance actually found on Mars. Because what may seem like just a simple image of rocks, fossils, or odd formations is far more complicated and far more exciting than it first appears. When scientists first spotted the strange formations in the images sent back from Perseverance, their excitement was palpable. These shapes, which appeared to have an almost fossilized quality, sent shockwaves through the research community. The formations had a striking resemblance to stromatolites, layered structures created by microbial life on Earth billions of years ago. In Earth's ancient past, stromatolites were one of the earliest forms of life, created by cyanobacteria that built up layers of minerals over time. Could it be that Mars once had something similar, ancient microbial communities that left behind similar structures? But before jumping to conclusions, let's break down why this discovery is so intriguing. To understand it fully, we need to dive into the science of what makes these Martian formations so special and why they've stirred such intense debate. First, consider Mars itself. It's often described as the red planet, a lifeless world with harsh conditions, extreme cold, high radiation, and a lack of liquid water on its surface. The Martian atmosphere is more than 95% carbon dioxide, and its surface pressure is less than 1% of Earth's. In other words, it's a world that seems entirely hostile to life. So why are we seeing these formations? Could they possibly be something more than just natural geological processes? The key to unlocking this mystery lies in one of Perseverance's main objectives, finding ancient signs of water. Why is water so important in the search for life? Water is the solvent of life. It's the medium in which life's biochemical reactions take place. It's no coincidence that when scientists search for life on other planets, they always begin by looking for water. Whether in its liquid form or frozen in ice, water is a crucial ingredient for life as we know it. Jezero Crater, where Perseverance landed, is the perfect place to search for ancient signs of water and, potentially, life. This crater is the site of an ancient Martian lake, one that once filled the bottom of the crater and spilled out into a delta. Deltas, like the ones on Earth, are rich with minerals that can trap and preserve biological materials. Over billions of years, these materials could have fossilized, creating records of life long after it disappeared. This is exactly what scientists were hoping to find when they selected Jezero Crater as Perseverance's landing site. The formations Perseverance discovered are located in an area of the crater known as the Delta Front. This is where ancient Martian rivers once flowed into the lake, carrying with them minerals, nutrients, and, potentially, life forms. VE. Shapes seen in the images don't look like typical mineral deposits or geological formations. They appear to have structure, with repetitive patterns that suggest they could be fossilized remains of microbial life, similar to what we see in the oldest rocks on Earth. The formation's symmetry is not random, and that's what sets it apart from other geological features found on Mars. So how can scientists confirm if these formations are actually fossils? The answer lies in chemical analysis. Perseverance is equipped with a suite of tools that are designed to study the composition of rocks and soil. The rover has already begun using its PIXL, Planetary Instrument for X-ray Lithochemistry, to analyze the chemical makeup of the Martian rocks and look for key indicators of life. These could include organic molecules, complex carbon-based compounds that are often associated with living organisms. If organic molecules are present, they could provide the first tangible evidence of life, past or present, on Mars. However, it's not just about finding organic molecules. Perseverance is also equipped with a tool called Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, which uses lasers to vaporize small portions of rocks, allowing scientists to study the chemical composition of the vapor. This can help detect mineral signatures that are often associated with life, such as certain types of minerals that form in the presence of water. But even if these tests turn up organic molecules or other signs of life, that still doesn't automatically mean that Mars was once home to living organisms. To definitively prove life once existed on Mars, scientists need more than just chemical evidence. They need context. They need to understand the geological history of the region and how the minerals and organic compounds found in the rocks came to be there. Did they form in a way that suggests biological activity, or could they have formed through purely chemical processes? This is where the rover's ability to collect samples becomes crucial. Perseverance is not just a camera on wheels. It's a robotic scientist. It has drilled into the Martian surface to collect rock and soil samples, and these will eventually be returned to Earth for more detailed analysis. Once back on Earth, scientists will have access to much more advanced laboratories with equipment far more sensitive and precise than anything available on Mars. These samples could reveal even more secrets about Mars's past, potentially unlocking the answer to the biggest question of all. Could life have once existed on Mars? But let's not forget, these findings also raise another fascinating possibility. Even if no evidence of ancient life is found in the samples, Perseverance's mission could still uncover something equally profound: the possibility of life existing on Mars today. The harsh conditions on Mars today don't necessarily rule out the existence of life in certain pockets, especially beneath the planet's surface. Microbial life, if it exists, could be living in the subsurface, where it is shielded from the harsh radiation and extreme temperatures on the surface. And in fact, some scientists believe that microbial life on Mars could still be alive in a dormant or cryptic form, waiting for the right conditions to awaken. For now, all we can do is wait. But this is the first step in a journey that could forever change how we think about life in the universe. Perseverance's mission is a pivotal moment in human exploration, and the evidence it uncovers could challenge everything we know about our place in the cosmos. Now, I know what you're thinking. This is mind-blowing, right? The potential to find life, ancient or present on Mars, is one of the most exciting scientific quests of our generation. But before we get too ahead of ourselves, let's take a moment to ask, what does this discovery really mean for us as a species? What impact will it have on how we view our place in the universe? At this point, we've explored the discovery itself, the tantalizing possibility that Perseverance has uncovered signs of ancient life on Mars. We've learned about the rover's instruments, the chemical analyses underway and the evidence we're piecing together. But now let's step back and think bigger. If Mars was once home to life, or if it still harbors life in some form today, what does that mean for us as humans? This discovery isn't just a scientific milestone, it's a philosophical one. It forces us to rethink our place in the universe and reimagine what life might look like beyond Earth. So what are the far-reaching implications of discovering life on Mars? First, let's consider what this would mean for the search for life beyond our planet. For centuries we've looked to the stars, wondering whether Earth is the only cradle for life in the universe. Even with the discovery of thousands of exoplanets, many of which exist in the habitable zone, where conditions might be right for life, our understanding of life's possibilities has remained largely speculative. But if we find definitive evidence of life on Mars, it would radically shift our perspective. It would suggest that life is not an anomaly, but perhaps a natural consequence of the right conditions. If life could emerge on Mars, why not on Europa, one of Jupiter's moons, or Enceladus, a moon of Saturn, both of which have subsurface oceans and could harbor microbial life? This discovery could be the key that opens the door to an entire universe filled with life, waiting to be discovered. But the implications of life on Mars go beyond just opening up the possibility of other forms of life in our solar system. It could also help answer one of the most profound questions in science: how did life begin? Currently, the prevailing theory is that life originated on Earth, likely in the primordial oceans, through a combination of chemical reactions that formed the first simple molecules, which then evolved into more complex organisms. But what if life didn't originate on Earth at all? What if life on Earth, and perhaps elsewhere in the universe, was seeded by microbial life that arrived from Mars or even further afield? This idea, called panspermia, suggests that life might not have started here at all, but rather life's building blocks traveled across space, hitching a ride on comets or asteroids, eventually arriving on Earth or other planets. If we find life on Mars, it would lend credence to this theory, changing our understanding of how life spreads across the cosmos. Let's pause for a moment and imagine what it would be like if humanity were to confirm that life did indeed once thrive on Mars. The implications are staggering, but let's focus on two key areas: human exploration and the future of space colonization. Space exploration is one of humanity's greatest achievements, and it's a journey that has only just begun. We've sent probes to the outer edges of the solar system, we've roved across the surface of Mars, and soon we'll send humans to the Moon again, and even Mars itself. But what would happen if we discovered that Mars had once been home to life? How would it change our goals and motivations for exploring the planet? We've always considered Mars to be a potential second home for humanity, a place where we could one day settle and build a new civilization. If we find life on Mars, it could completely alter how we approach that mission. For one, we would need to consider the ethics of colonizing a planet that may still harbor microbial life, even if it's dormant. Would we risk contaminating Mars with Earth life, disrupting a potential ecosystem that could still exist beneath the surface? The discovery of life would raise serious questions about our responsibility as explorers, and that responsibility could change the way we approach all future space missions. There's also the psychological impact. For decades, humanity has wondered if we're alone in the universe. The discovery of even the most basic life forms on Mars would fundamentally alter the way we view ourselves and our place in the cosmos. Imagine the moment when it's confirmed. This isn't just the end of a scientific quest, it's the beginning of a new era in human understanding. It's the realization that life is far more common in the universe than we ever thought. It's the moment when we understand that we are not isolated in the vastness of space. We are part of something much bigger. Now, let's talk about what this means for the future of space colonization. If life on Mars can be proven, how might that influence our efforts to colonize the planet? Some scientists argue that if we confirm life once existed, or still exists on Mars, the prospect of human colonization might become more complicated. What if Mars still harbors dormant or microbial life beneath its surface? Would we need to reconsider our efforts to terraform Mars or introduce Earth organisms into its ecosystem? out of respect for the possibility of indigenous life. The discovery of life would force us to approach the colonization of Mars with a far more cautious, ethical mindset, recognizing the planet's potential to harbor unique life forms that deserve protection. But on the other hand, the discovery could also boost efforts to colonize Mars. Knowing that life once existed on the red planet would reinforce the idea that Mars could be a sustainable home for humanity in the future. The presence of water. In Mars' distant past, combined with the discovery of possible organic compounds, suggests that the planet was once far more hospitable than it is today. With the right technology, we could potentially restore parts of Mars to a more Earth-like state, creating an environment where humans could live. In fact, NASA's plans for Mars colonization are already in motion, with private companies like SpaceX planning missions to send humans to Mars as early as the mid-2020s. If life on Mars is confirmed, those plans could be fast-tracked, with the hope that the planet's history of supporting life could mean that our own future on Mars is more achievable than ever before. Of course, there are still many unknowns. The challenges of surviving on Mars are immense. Extreme temperatures, radiation, and the difficulty of sustaining life without Earth's resources are just a few of the obstacles. But the discovery of life would be an enormous step forward, providing the proof that Mars, once a thriving planet, could support life, and could potentially support human life again. This discovery would also carry immense cultural and philosophical weight. For centuries, humanity has looked up at the stars and asked, are we alone? If we find life on Mars, we will have our answer. And that answer won't just be about biology. It will force us to confront profound questions about the meaning of life, the nature of existence, and humanity's place in the vast universe. It will challenge our assumptions about what life is, where it can exist, and how it spreads across the cosmos. So, with all of this in mind, what's next? If life on Mars is confirmed, whether ancient or present, it will mark a new era for humanity. It will be a moment that changes everything. And the journey to that moment has only just begun. Now that we've walked through the exhilarating implications of finding life on Mars, it's time to look ahead. If Perseverance's discoveries are just the beginning, what's next? What future steps will scientists take to confirm or potentially dismiss this tantalizing possibility? And how will humanity respond if Mars truly holds signs of life? The mission of Perseverance is far from over. In fact, the rover's journey is just beginning, and there's so much more to discover. While its first year on Mars has already yielded incredible images and data, it's only just started scratching the surface of what's buried beneath the Martian soil. To get to the heart of this mystery, whether these strange formations are signs of ancient life, chemical processes, or something else entirely, we need more than just initial data. We need to go deeper. One of Perseverance's primary tasks now is to continue its search for organic compounds and trace elements that could point to microbial life. The rover's instruments are designed to detect these signs, but it's a delicate process. Organic molecules, if present, are incredibly subtle, tiny traces that could easily be overlooked. The rover is carefully navigating Mars's surface, taking rock samples from multiple locations, drilling into the Martian soil, and gathering material that may have been untouched for millions of years. These samples will later be sent to Earth, thanks to the Mars Sample Return mission. But until then, the data Perseverance collects could help us understand if Mars truly harbors, or ever harbored, life. Now let's think about what those samples might reveal. Could they hold the smoking gun, the chemical signatures that prove life once existed on Mars? The anticipation is electric, because if those samples do contain organic molecules or other biomarkers, it would be nothing short of a breakthrough. It's one thing to theorize about life on Mars. It's another thing to hold the evidence in our hands. And if that evidence points to past life, what happens next? The confirmation of life, whether microbial or more complex, would open up a floodgate of scientific inquiry. For one, it would spark a new wave of exploration, not just on Mars but across our entire solar system. If Mars, with its ancient lakes and rivers, hosted life, could other worlds with similar conditions also support life? Europa, with its hidden oceans beneath layers of ice, Enceladus, spewing geysers of water vapor and organic compounds from its subsurface, these moons would suddenly rise to the top of our list of places to explore. And beyond our solar system, the discovery of life on Mars could redefine the search for habitable planets around distant stars, shifting the focus from if we find life to where we find it. But let's not forget the human side of this discovery. If life is found on Mars, it will change us forever. Imagine the moment when that news hits Earth. The announcement would ripple through every corner of the world. Scientists, politicians, philosophers, and everyday people would all grapple with the implications. It would be the ultimate confirmation that we are not alone, that the universe teems with possibilities, with life forms we've yet to comprehend. It could unite humanity in a shared sense of awe, wonder, and even responsibility. And speaking of responsibility, if life is found on Mars, it will change the ethical landscape of space exploration. Right now, when we think about colonizing Mars, the discussion centers on the technical challenges: how to grow food, how to create breathable air, how to survive the harsh conditions. But the discovery of life on Mars would force us to consider deeper moral questions. If microbial life exists, even in a dormant state, should we proceed with terraforming the planet? What would it mean to disturb an ecosystem, even one we can't fully understand? Would we be wise to preserve Mars as it is, even if that means our dream of colonizing it may need to wait? The ethical debate surrounding Mars exploration and colonization is not just a question for scientists. It's something we, as a species, will need to address. Should we exploit Mars for our own survival, or should we protect it as a potential sanctuary for life? What would be the true cost of making Mars our second home? This is a question that will spark debates for decades to come. Yet no matter what happens, one thing is certain. The discovery of life on Mars would send ripples through every aspect of our society. It would transform the scientific community, the way we view our future in space, and even the way we perceive life here on Earth. It might challenge us to re-evaluate our place in the universe and rethink how we relate to other forms of life, both on Mars and elsewhere. But beyond the philosophical and ethical implications, what comes next for Perseverance specifically? Perseverance is not just a scientist in a robotic body, it's a trailblazer. It will continue to study the Martian surface, collect data, and send back valuable samples. As its mission progresses, Perseverance will journey farther into the heart of Jezero crater, unlocking more of Mars' geological history. Each new discovery could add another piece to the puzzle of Mars's past, and perhaps even give us the clues we need to confirm whether life ever took root there. And let's not forget about the Mars Sample Return mission, which is the next giant leap in this scientific quest. The rover will send its collected samples back to Earth in the coming years, where they'll be analyzed with cutting-edge techniques that we can only dream of on Mars. Scientists will have the chance to study these samples in the same labs that have unlocked the secrets of our own planet's ancient history. With this return of Martian material, humanity will finally have access to a treasure trove of data that could answer the most pressing question of all. Was there life on Mars? But we're not stopping at Mars. Perseverance is part of a broader effort to understand whether life exists elsewhere in the solar system. Future missions will likely explore the icy moons of Jupiter and Saturn, places where subsurface oceans may hide the key to extraterrestrial life. These moons, Europa, Enceladus, are quickly becoming the new frontiers of astrobiology. Could they harbor life beneath their icy shells? Perseverance is helping us prepare for the next stage of our search, one that could take us farther from Earth than ever before. As we look ahead, it's clear that we are at the dawn of an incredible new chapter in space exploration. Whether or not Perseverance finds definitive evidence of life, it has already changed the course of our future. The discoveries we make today will lay the groundwork for the missions of tomorrow, and as we explore Mars, the Moon, and beyond, we will continue to search for the answer to one of humanity's most profound questions. Are we alone? So I'll leave you with this. The search for life in the universe is not just a scientific mission, it's a journey that will shape who we are as a species, challenge our assumptions about life, and redefine what it means to be human. The future of space exploration is unfolding before our eyes, and we are part of this story. Now I want to hear from you. What do you think this discovery means? How will it change the way we think about life, space exploration, and our place in the cosmos? Share your thoughts in the comments below, and let's continue this conversation. And if you've enjoyed unraveling these mysteries with me, like this video and share it with others who are just as curious about the universe.